Hey guys, welcome back to lesson 2 of trigonometry, where today we're going to be covering the Pythagoras theorem. So that the Pythagoras theorem only applies to right angle triangles. So something like this, I believe you guys should know from the previous lesson, and it's in the name right angle triangle. So today we're just going to be going over the theorem and solving some problems, rearranging the theorem, sort of playing around with it, and I'll put up some questions. So first of all, we have a right angle triangle. Right now, if if you're a beginner, then I'd suggest that when you're doing a problem, you label your triangle. So your right angle triangle. So we start off with A, B, and C. C is the longest side of the right angle triangle. So the Pythagoras theorem basically states that c squared equals a squared plus b squared, and so forth. And basically what this is it's to calculate the hypotenuse length, which is the longest length of the right angle triangle. So next up, we will also rearrange. Let's rearrange. Say if we want to calculate a. So then we put a squared equals c squared minus b squared. Basically, it's just changing the position of these two. But also one thing you should remember well is just make sure that c squared is always first, because c squared is the longer side, so you want to always have the biggest number and take away a smaller number. So in this situation, then you'd end up with a positive number. But if you were to inverse it, b squared minus c squared, then you'd get a negative number. So, and henceforth, we also will calculate b squared, which is c squared minus a squared. Okay, so you can get these notes down in your book, and then we'll move on to some basic Pythagoras questions. So yeah. Okay, so the first question I'd like you to solve is this one here. So we have a little right angle triangle, and so I'd like you to calculate this length here, and let's give this 40 centimeters. Oops, 40 centimeters and 9 centimeters sound good for this. So I'll leave it to you to label the right angle triangle from the previous lesson, and then you can calculate using the Pythagoras theorem. A squared plus b squared equals c squared. And I'll only put up the formula for this one here. The next one I'll let you guys do it, see if you've understood. Okay, so now calculating this length here, which I hope you have labeled as the hypotenuse. This is our adjacent and this is our opposite. So, but we don't need that. We just kind of need to calculate the hypotenuse length here. So, substituting this into the theorem, we can say that x squared equals 40 squared. Sorry, plus. Oops, I shouldn't really. 40 squared plus 40 squared plus 9 squared. And then what we're going to write is, and then we're going to evaluate these. So x squared equals 40 squared, 1600, and 9 squared is 81, so 1600 plus 81, and then x squared is equivalent to 1681, except we're just, because we're dealing with squares, it also means we have to deal with square roots. So that means that we're going to rip off this square, and we're going to put this into a square root. And so 1681 is, so square root of 1681 gives us, we get 41. So x equals 41 centimeters. And if you got that, well done. Alright, so let's move on to another problem that I'm gonna let you guys do. So, say we have a right angle triangle. Very, very simple question, this one is too, but it's just if you can substitute the formula. So, that's a terrible theta. Right, okay, so I'm just going to give you some units here. 5 meters, label that as y, and I think hypotenuse is good for 8 meters. Alright, so I'd like you to solve this question here, and then we'll solve it together. So basically, rearranging the theorem where we are solving for b squared, we're just going to write b squared equals c squared minus a squared. I should put in better a. So b squared equals c squared minus a squared, and then we're going to do b squared. Well, I should actually redo that for y. Y squared equals 8 squared minus 5 squared. Y squared equals 64 minus 25. I believe y, I think that's 39. Y equals 30. Whoops. Y equals 39. Yep. And then y is equal to the square root of 39. And then we're just gonna evaluate that. And which equals to 6 rounding it nicely, 6.245. 6.245 meters. And so that is the answer to this question here. And it's fairly simple, to be honest. And I'll create up another problem, and then we'll just solve that one, and that'll be it for today. By then, you should have pretty much understood the Pythagoras theorem fairly well. Okay, so this problem here, we're just gonna draw another right angle triangle, and I'd like you to calculate this x, marked x. I'm gonna give this 7, and I'm gonna give this 9. So I'd like you to solve for this side here, and so we'll solve that together once you have done your working out. It's pretty simple. Once again, rearrangement of the formula, where actually instead of referring it to as a, I will refer it to x. So x squared is equal to 9 squared minus 7 squared, and then x squared equals 81 minus 49, and then x squared equals and then basically here x equals the square root of 32, and then x equals, let's just quickly put that in 6.244. Running 3 significant figures, actually 6.245. What? Is that the same answer? I think from the previous one? Yeah, I think it's the same answer. What a coincidence. I just made this one up by myself, and it ended up having the same answer. So that's it basically. If you got 6.245, then well done. So that's pretty much it for the Pythagoras theorem. You have learned to substitute the theorem from c squared equals a squared. Whoops. Okay, why did I delete the c squared? No, c squared equals a squared plus b squared, and then a squared equals c squared minus b squared, and then b squared equals c squared minus a squared. So you've learned how to substitute the formula as well as you've also reinforced on being able to correctly label the side of a right angle triangle. And I actually noticed in the previous problem I made a mistake where I actually didn't put theta, but that's not a problem because you already know A, B, and C, right? So A, B, and C sort of just substitute in for theta, to be honest. So It just tells you where you really are, you know. So thanks. I hope this lesson really helped, and a like and a subscribe would be much appreciated. Thanks, guys. Bye.